Hello, my name is Brian Dick. I'm a software engineer, and this is my YouTube tutorial series on solving the HackerRank interview preparation kit problems. Currently, we are going over dictionaries and hash maps, and this problem in particular is the Sherlock and Anagrams problem. Let's begin. This problem is of medium difficulty, and this is the problem itself. Two strings are anagrams of each other if the letters of one string can be arranged to form the other string. Given a string, find the number of pairs of substrings of the string that are anagrams of each other. For example, S is equal to mom. The list of all anagrammic pairs is MM, MO, at positions 0, 2, and 0, 1, 1, 2, respectively. So it's important to note that they are defining an anagram as any permutation of the same characters that are at separate points of this array. Function description. Complete a function, Sherlock and anagrams in the editor below. It must return an integer that represents the number of anagrammic pairs of substrings in S. Sherlock and anagrams has the following parameters. S, a string. So we're given a simple string. We're told that the constraints are there's going to be less than 10 queries and more than 2, but less than 100 characters in the string. Let's see here, for each query, return the number of unordered anagrammic pairs. It gives us some examples here. I think one in particular that's really helpful is the 4K problem. So 4Ks returns 10 anagrams. The reason for this, as it explains below, is there's 6 of the form KK, and then it basically is explaining that every permutation counts as its own separate anagram. So here you have an anagram of 0 and 1, but you also have 0 and 2, and you also have 0 and 3, and you also have 1 and 2, 1 and 3, and 2 and 3, giving you a total of 6 anagrams for the permutations of just the KKs. And this is in line with the n-1 times n divided by 2 format for calculating how many different permutations of a list is. So if we have 4 Ks, right? n-1, that's 3. 3 times 4 is 12, and then you divide 12 by 2, that gives you 6. So that's the total number of permutations you have in a sequence of 4. Right? So if I had numbers 1, 2, 3, 4, and I wanted to get that every permutation, I know that there's a total of 6 permutations that can be done. So that's just interesting to note. Yeah, I think with that information, we have everything we need to get into this problem. So I am going to take a sip of water. All right. Now let's get to the problem. So first we're going to want a map. So Sdd map. We're going to be keeping track of the strings, which are the substrings, and an integer, which represents the number of occurrences. And we'll call this the substring table. Now, one thing that we want to do to make this a little bit less tedious is we want to sort the strings as we're adding them to the table. So all of the substrings that result in an anagram will automatically be in the same key. So we only have to look up a single anagram value to be able to determine if it's in the anagram or not. The tricky part here is this outer and inner for loop structure, which is going to be used to get every single permutation of the array. And for this, if you don't already know how to get all of the permutations, this information is a Google search away. But effectively, what we're going to do is we're going to create an outer and an inner for loop. The outer for loop starts at 0 and goes up until the size of the array. And then the inner for loop is going to start at 1 and go until we're at, j is less than or equal to the end of the array. But to get the end of the array, since this is a inner loop, and we only want to go until from whatever point I is until the end, then we are going to be using the s.size and then subtracting I from it. And of course, we're going to increment through all the values of j to that point. Now that we have our intersection here, we can do a string. We'll call this string substring is equal to the s.substring method. And for this, we take in a beginning index and a ending index, which is I and j respectively. Next, we're going to want to use the Sdd Sort method, which takes in an iterator pointing to the beginning of the object that we want to sort, and another iterator that points to the end of the object we want to sort. And that should do it. Now, a fun aside is this sort function will work on any object in C++ that contains an iterator, so that it has to be iterable, and also has a comparison function. So strings, obviously, since it's part of the standard library, it's going to have these parameters. So we do have an iterator that points to the beginning and an iterator that points to the end, and it does have a comparable function in that it can determine where it is in ASCII values. If none of that makes any sense to you, it's not that important, but I just thought it would be a nice aside. So now we're going to compare if our substring table dot count of our substring, which has now been sorted. It's important to note that it's been sorted. So if our count of the keys, so that's what this is. So if you have on a map, the map has a count function. Count returns the number of occurrences of the key. So it'll return 0 if it is not in the function. It'll return some number that relates to something otherwise. But just know that it is 0 if it is not found, and that's essentially what we're using this for. You could also check to see if you can find the key, and if that doesn't work, then that's and if that returns an iterator to the end of the map, that'll also be useful enough. Okay, so let's check to see. So inside of here, we're going to say substring substring is, or sorry, not substrings, substring table substring is equal to 1, and then else substring table of substring plus equal 1. So basically, if we didn't have it, we now have 1. If we did have it, we now have another 1. So once we go through these for loops, the inner and outer, and get out of the outer, we now will have every permutation of the string stored in the dictionary with all of the substrings sorted, which means that they are all the anagrams are paired together, and we have the number of anagrams of that type. So let's go outside of that second for loop and say int count is equal to 0, because currently we do not have any anagrams that we know of. And then we're going to create a for loop that uses the iterator for this string table. So we'll call it is equal to substring table dot begin, while it is not equal to substring table dot end. We'll continue going, and then we'll increment t, or iterator. And let me just move this way so you can see everything. That might make it a little bit more readable. So inside of here, we're going to say our int val, for short for value, is equal to it second. Now on an iterator is just a pointer to the location in memory where an object exists, and it knows how big of a step to take. So in this case, we have a string and an integer, so we have a certain amount of space laid out in memory that keeps track of these. In a map, when you have an iterator to the map, the first is a pointer to the key, and the second is a pointer to the value. So here we are getting the value stored, or the integer stored at the key for every key in our map. So in this case in particular, we're grabbing that the number of occurrences of this sorted substring. In other words, the anagram. We're then going to check to see if val is greater than 1. So if the value is greater than 1, that means that we've seen more than one of these, which means we have at least a pair. We can then apply the probability thingy. I'm not sure, I can't remember the name of the rule, but basically it gets all the permutations for a given set. So you can say count plus equals, and it is val times val minus 1 divided by 2. And this here should give us the number of possible permutations according to the number of anagrams we have, which in turn is the total number of anagrams we need to count. After we get outside of this for loop, we should have counted up all of our anagrams, and we can simply return our count. Let's see if this runs. And there we go. We passed all of our sample test cases, and we'll go ahead and submit the code. It looks like we have all green. So if this tutorial helped you solve the Sherlock and Anagrams problem, be sure you give this video a thumbs up. If you need further explanation on anything I covered in this video, please leave your questions below. I'll be happy to get back to you as soon as possible. If you want to see more of these videos, be sure you subscribe to the channel and hit the notification bell. I'm going to be going through the entire interview preparation kit problems one by one and breaking them down like this, some in more depth than others, depending on the difficulty I think it requires. And yeah, thanks for watching, and I'll see you next time.